Hello everyone, myself Prateek Raj from class 10th HB, and today I'm going to discuss some of the key points and facts about the chapter coordinate geometry. Let's start. Firstly, we will start with the introduction. Coordinate geometry or analytical geometry is defined as the study of geometry using the coordinate points. Using coordinate geometry, it is possible to find the distance between 2 points, dividing the lines in m:n ratio, finding the midpoint of a line, calculating the area of a triangle in Cartesian plane, etc. Now, what is a coordinate and a coordinate plane? You must be familiar with plotting graphs on a plane. From the tables of numbers for both linear equation and nonlinear equations, the number line, which is also known as Cartesian plane, is divided into 4 quadrants by 2 axes perpendicular to each other, labeled as the x-axis or abscissa, the horizontal line, and the y-axis or ordinate, vertical line. The 4 quadrants along with their respective values are represented in the graph below. The quadrants are quadrant 1 x comma y, quadrant 2 minus x comma y, quadrant 3 minus x comma minus y, and quadrant 4 x comma minus y. The location of any point on a plane is expressed by a pair of values x comma y, and these pairs are known as the coordinate. The point at which the axes intersect is known as the origin and has a coordinate of 0, 0. So here are some examples of Cartesian plane, as you can see. Now we will see distance formula. So the distance formula is used to calculate the distance between 2 points. The distance formula is derived by creating a triangle and the length of the hypotenuse is taken out using the Pythagoras theorem. The hypotenuse of the triangle is the distance between the 2 points. The formula to find distance is d equals root under x2 minus x1 whole square plus y2 minus y1 whole square. Properties of various types of quadrilateral in distance formula. Now, a quadrilateral is a rectangle if its opposite sides are equal and the diagonals are equal. Square if all its sides are equal and diagonals are equal. Parallelogram if its opposite sides are equal. Parallelogram but not a rectangle if its opposite sides are equal but diagonals are not equal. Rhombus but not a square if all its sides are equal and the diagonals are not equal. Now we will see the section formula. So when a point divides a line segment internally or externally in some ratio, the formula used to determine the coordinates of that point is known as the section formula. Let us say we have a point P x comma y that divides the line segment with marked points as ax1 comma y1 and bx2 comma y2. To find the coordinates, we use section formula, which is mathematically expressed as px comma y equals mx2 plus nx1 upon m plus n, comma my2 plus ny1 upon m plus n. Note, here m and n define the division of line segment into a ratio m is to n. Section formula in coordinate geometry is mainly divided into sub-formulas, which are internal section formula, external section formula, and the midpoint formula. Now we will see internal section formula. So the internal section formula is used when the line segment is divided internally by a point in the given desired ratio. This formula is used to find the coordinates of a point which falls between the 2 points and on the line joining these 2 points in the given ratio. The line segment AB is divided by a point Px, y internally in a ratio such that AP is to PB equals M is to N. Then the coordinates of the point P in terms of the given ratio and for the given coordinates of the points ax1, y1, bx2, y2 is px, y equals mx2 plus nx1 upon m plus n, comma my2 plus ny1 upon m plus n, where x and y are the coordinates of point P, x1, y1 are the Cartesian coordinates of point A, x2 and y2 are the coordinates of the point B, m and n are the ratio values in which P divides the line internally. Now external section formula. The external section formula is used when the line segment is divided externally by the point in the given ratio. The formula is used to find the coordinates of the point on the line segment joining the 2 points and falling beyond the 2 points in the given ratio. The line segment AB is divided by a point Px, y externally in a ratio such that AP is to PB equals M is to N. Then the coordinates of the point P in terms of given ratio and for the given coordinates of the points A x1, y1, B x2, y2 is Px, y equals mx2 minus nx1 upon m minus n, my2 minus ny1 upon m minus n, where x and y are the coordinates of point P, x1, y1 are the coordinates of point A, x2, y2 are the coordinates of the point B, m and n are the ratio values in which P divides the line externally. Section formula for midpoint or midpoint formula. The midpoint formula is used to find the coordinates of the midpoint of a line segment. Here the ratio between the two parts is 1:1. A midpoint refers to a point that is exactly in the middle of the line segment. We can derive the midpoint formula using the section formula for or find the midpoint of any line segment using the section formula as mx, y equals mx2 plus nx1 upon m plus n and my2 plus ny1 upon m plus n. Putting m equals 1 and n equals 1, we get mx upon x, y equals x2 plus x1 upon 2 and y2 plus y1 upon 2, where x and y are the coordinates of point M, x1 and y1 are the coordinates of point J, and x2 and y2 are the coordinates of the point K. Now we will see a centroid formula. The geometric center of the object is known as centroid. For determining the coordinates of triangle centroid, we use centroid formula. The centroid of a triangle can be determined as the point of intersection of all the three medians of the triangle. The centroid of a triangle divides all the medians in a 2:1 ratio. What is a centroid in respect of a triangle? So the centroid of a triangle is the center of the triangle. It is referred to as the point of concurrency of medians of a triangle. Centroid formula. The centroid formula of a given triangle can be expressed as G equals x1 plus x2 plus x3 upon 3 and y1 plus y2 plus y3 upon 3, where G denotes the centroid of a triangle, x1, x2 and x3 are the coordinates at the x coordinates of the three vertices, y1, y2 and y3 are the y coordinates of the three vertices. Now we will see area of triangles. In geometry, a triangle is a three-sided polygon that has three edges and three vertices. The area of triangle is the space covered by the triangle in a two-dimensional plane. The formula for area of a triangle is half into base into altitude. In coordinate geometry, the area of triangle can be calculated if three vertices of the triangle are given in coordinate plane. The area of triangle in coordinate geometry is defined as the area or space covered by it in the 2D coordinate plane. The formula for area of triangle is half x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. And as the area is always positive, therefore the area of triangle is half into mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Now we will see condition for collinearity of 3 points in a triangle. Let the given points be A x1 y1, B x2 y2 and C x3 y3. Then A, B, C and are collinear. So area of triangle ABC equals 0. So half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 equals 0. That is x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 equals 0. Now let us quickly look at the summary of the chapter. Firstly, we saw introduction to coordinates and coordinate geometry, some examples of Cartesian plane, distance formula, then we saw section formula and its subformulas, then centroid formula, then area of triangles, and finally condition of collinearity of 3 points of triangle. So thank you for having with me.